In this question, I have a right angle triangle with corners A, B, and C, and it is told that the coordinates of point A are 1, 3, the coordinates of point B are 5, 11, and angle ABC is 90 degrees. This is 90 degrees. The point X 4, 4 lies on line AC. This is point X which lies on line AC, and I need to find the equation of line BC. I need to find the equation of this line and the coordinates of point C. I need to find the coordinates of this point. So first, to find the equation of line BC, to find the equation we use this formula y minus y1 is equal to m times x minus x1. In order to use this formula, first I need to know the gradient, and second I need to know a point on the line. Well, first, to find the gradient, I only have one point on this line, so I can't use the formula of the gradient here because I only have one point. But what I can do over here is that I can use the fact that there is a 90-degree angle between these two lines. When two lines are perpendicular to each other, we use the relationship m1 times m2 is equal to -1, which says that the product of the gradient of two perpendicular lines is equal to -1. Since line AB is perpendicular to BC and I know 2 points on line AB, I can use the formula for gradient for this line. So if the gradient of this line is m1, m1 is going to be equal to y2 minus y1 divided by x2 minus x1. I am going to take this point as x1 y1 and this as x2 y2, and I will get 11 minus 3 divided by 5 minus 1. This would give me 8 upon 4, which is 2. So the gradient of this line is 2. Now I'll use this relationship. This is going to be 2 times the gradient of line BC. Let's say that the gradient of this line is m2. So 2 times m2 is going to be equal to -1. And this gives me m2 as -1 upon 2. So the gradient of this line is -1 upon 2. Now since I know the gradient, the point is also given. I'll use this point for this equation. So x1 is going to be 5 and y1 is going to be 11. So now I can find the equation. It would be y minus 11 is equal to -1 upon 2, the gradient, times x minus x1, which is 5. This would give me y minus 11 is equal to -1 upon 2x plus 5 upon 2. Adding 11 on both sides would give me y is equal to -1 upon 2x plus 5 upon 2 plus 11. 5 upon 2 plus 11 is y is equal to -1 upon 2x plus 27 upon 2. So this is the equation of line BC. It's y is equal to -1 upon 2x plus 27 upon 2. Now next, for the coordinates of point C, I know that point C is the point of intersection of this line and of this line. So if I solve the equations of these two lines simultaneously, I'll get the coordinates of point C. I know the equation of this line which we found in part 1. It's y is equal to -1 upon 2x plus 27 upon 2. But I don't know the equation of line AC. So I'll first find the equation of line AC and then solve these two equations simultaneously to find the coordinates of point C. So first, for equation AC, I'll use the formula y minus y1 is equal to m times x minus x1. To use this formula, first I need to know the gradient, and second, a point on the line. For the gradient, I have 2 points on the line. A is known and point x is also known. So I can find the gradient of line AC by using the formula y2 minus y1 divided by x2 minus x1. If this is x1 y1 and this is x2 y2, the gradient would be 4 minus 3 divided by 4 minus 1. This would give me 1 upon 3. So the gradient of this line is 1 upon 3. 2 points on the line are known. I can use any point. So let's say I'm going to use this point here. So the equation is going to be y minus 3 is equal to 1 upon 3 times x minus x1, which is 1. This would give me y minus 3 is equal to 1 upon 3x minus 1 upon 3. Adding 3 on both sides would give me y is equal to 1 upon 3x minus 1 upon 3 plus 3. Minus 1 upon 3 plus 3 is 8 upon 3. So the equation would be y is equal to 1 upon 3x plus 8 upon 3. This is the equation of line AC. Now for the coordinates of point C, I am going to solve the equation of this line BC, which is y is equal to minus 1 upon 2x plus 27 upon 2, and the equation of line AC, which is y is equal to 1 upon 3x plus 8 upon 3. This is equation 1 and this is equation 2. Y is already a subject in both of these equations, so I'll equate these two and I'll get 1 upon 3x plus 8 upon 3 is equal to minus 1 upon 2x plus 27 upon 2. Shifting terms with x on one side and the terms without x on the other would give me 1 upon 3x plus 1 upon 2x is equal to 27 upon 2 minus 8 upon 3. 1 upon 3x plus 1 upon 2x is 5 upon 6x, and 27 upon 2 minus 8 upon 3 is 65 upon 6. Cross multiplying would give me x as 65 upon 5, which is 13. So the x coordinate of this point is 13. Now for the y coordinate, I'll substitute this 13 in equation 1 and I'll get y is equal to minus 1 upon 2 times 13 plus 27 upon 2. And solving this would give me y as 7. So the y coordinate of point C is 7. This is the answer to the second part of the question.